Try to picture yourself in the following situation. You are a developer and you have done your job of instrumenting your microservices to produce tracing data. And the same tracing data is being used already by the observability team to monitor and follow up the execution of your code and production. But one day they come back to you and say, you know what? I have noticed that whatever we are seeing in the observability backend doesn't seem to reflect what your code is doing. Something is a little off. What can you do about it? In this video, I'm going to show you how to solve that problem using the OpenTelemetry SDK. Hello there and welcome. My name is Ricardo Ferreira and I'm a developer advocate here with AWS. This video is going to be focused in demonstrating how to solve one of the most common problems that happens during the implementation of any observability project, which is the gap that exists about the telemetry data produced by your microservices and code in general and what the observability backend receives. To better understand about how this problem occurs, let's analyze it through a hypothetical scenario. So let's say, for example, that I have been escalated to investigate a problem that happened in production. Since I know that one of the microservices that were part of that transaction generates telemetry data specifically for traces, my natural instinct is going to use the observability backend to analyze those traces. So this is what I'm going to do now. I'm going to actually retrieve all the traces generated by microservices called Hello App, and then I am going to search for the traces generated. So as you can see here, there are two traces generated. I can pick up one of them to start my investigation process. And when I am doing this investigation, I start noticing that perhaps the view that I'm looking here to the tracing timeline might not be the complete view of what the code was doing. So this is when I start suspecting that what I'm looking at here might not be the actual reality. So there are a couple options that you can do to solve that problem. The first option is if you don't have access to the code, you can try to look to the logs generated from the code and try to match if the sequence of events are the same. Most of the time, this is not a golden rule, but most of the time, the code is going to produce a log for each part of the function executed from the code, right? And so you can at least go a little deeper in this investigation process. The better approach, the approach that usually we recommend is to, if you have access to the code, go to take a look at the code and try to see if that matches with the timeline of event are showing. So let's try to do this exercise right now. So as of now, we can see that when the microservice is executed, this entry point /hello with touch, and then right below this function called hello app controller.hello was executed. So if we look to the code, we can actually double check that information. So as you can see here, this is the Java class that implements that microservice. And this is the actual hello app controller that were shown before. And this function over here called hello is the entry point of the execution of the code. So as you can see here, it matches to what we are looking here. So after /hello entry point was executed this hello app controller.hello, which is this method from this Java class. However, we can clearly see here that right below that method, there was a couple more code executed. So where is this execution of that entry called build response, which is another function of the code that creates an object and do something else? So this is when we have the complete and absolute sure that the timeline events, it's not showing what the actual code is doing. And there has to be a way to fix that. And the way to fix this is using a better or deeper instrumentation approach, which is usually known as the manual instrumentation approach. A manual instrumentation approach is when the developers that produce the code, or perhaps a developer team that is responsible only for instrumentation, to go back into the microservices or the source application that produced that data and to include additional code that is going to encapsulate everything what the code is actually doing it. And this is the process that we're going to do right now using the OpenTelemetry SDK. Before we proceed, please note that the code that we're using for this example is available on GitHub. take a look here in the comments below, and you're going to find the GitHub repository that contains the implementation of this Java microservice. Just be mindful that when you clone that repository, use that specific branch called build on AWS tutorial. So the manual instrumentation usually starts by including the dependencies of the instrumentation library that you intend to use. In case of OpenTelemetry, it makes available SDKs for the many programming languages that are available out there. So in case of Java, you have to include the dependencies on this project. So since this project is using Maven as the building and automation process, we're going to use this pom.xml file to declare those dependencies. So the dependencies are going to need to use the versions of the specific release of the instrumentation library. So what I'm going to do right now is to include two properties that are going to dictate the version from the API for traces and the version for the API for the matrix. And they're going to be treated some sort of like a global variables and reuse it throughout the whole POM file. So now that we have defined those properties, I can actually start the inclusion of the 4 dependencies that this project is going to need. So the dependencies themselves, I'm going to add them here in the list, and they're going to be the API from OpenTelemetry, the special dependencies that provide support for annotations in Java, and then the API for traces and matrix. So save that file, and then you can go back to the implementation of your Java class that provides the code that you want to highlight in the observability backend. So the instrumentation process in Java specifically usually starts by you providing support for something that we call a tracer. So I'm going to provide the imports here for whatever we're going to put in the code and in a sequence. And a tracer is a component that is responsible for creating custom spans. So you might have heard me saying in previous videos using the terms root span and child span. So the root span is what is automatically generated when the microservice touches its entry point. And in this case of this Spring Boot microservice is when happens the execution, that function here that represents the entry point of the REST API exposed by this microservice. So the /hello is going to be the root span. From that root span is going to be generated one or multiple child spans, right? So that's what we are intending to do. And that's why we need this component called a tracer. So I'm going to include the import for this Spring Boot annotation here. I'll add value. And then you can create a tracer by calling this Java singleton class called global OpenTelemetry, and then invoking the method getTracer. When you invoke that method, you can provide a string. This is whatever you want to call it, just for the sake of when you are debugging instrumentation, you can easily identify what tracer you're talking about. And then as a best practice, to also provide the version of the SDK that you were using, also for troubleshooting purposes. So now that we have a tracer created, we can actually create our own child span. So the first child span that we're going to create is going to be called mySpan. So this is going to be created right after the execution of this build response invocation call. So as you can see here, we've jumped at this invocation for the build response method, and then we're actually creating this object called span from the tracer that we've defined here. So to create a span, you basically call the method spanBuilder, and then you provide a name for the span. In this case, we're calling mySpan, and then you are going to start the span. So what this start span method actually does is to set the precise timestamp that corresponds to the exact time when the execution of the code started. So this is extremely important because one of the points that you want to measure with this instrumentation process is how long does it take for a certain piece of code to execute. So you have to always start and finish your spans. So now, since we are using this pattern of a builder, we're not only creating the span, but also starting at the same time. So now that we have started a span, we're going to use it in one specific scope, as we call it in the OpenTelemetry SDK, And then whatever happens here in this scope is what's going to comprehend what that specific span did. So you can think about that as like you are highlighting the intention of that particular piece of code, right? So, and after this, you are going to end that span. So what does it mean? It means that you are informing the instrumentation process that that span just finished its execution. So it can start the clock of measuring how long did it take to execute that part of the code. So you start the clock by calling start span, and you finish the clock by ending that span, right? So now that we have one span manually created from the tracer, this is one of the ways that you can create your own child span. So as you can see here, basically you have to define a tracer, and this tracer is usually going to be created only once per Java class or per module or per package. It doesn't need to actually create multiple tracer in your code. This has to be treated not only as a single tool object, but also as a stateful object. So from one tracer, you can create as many child spans as you want it. So one of the ways to create your own span is using this approach, which is what I call the manual approach. The other approach is using a specific annotation called @WithSpan. So just to explain what we're going to do right now, so let's recap. The root span is going to be this hello method that, as you know, is going to be automatically created by the whole automatic instrumentation from the JVM, the OpenTelemetry agent for Java. But we are now creating this manual span called mySpan. But before this, we also want to highlight that this function build response was executed. So what you can do is option number one, you can use the same strategy that we have used before and from the tracer create our own span over here. But in order to avoid this boilerplate code of creating the span and start the span and finish the span, we can simply annotate your Java method with this annotation @WithSpan here. So when you do this, this is the equivalent. We're actually not doing something different. It's just a simpler way to do exactly this, right? So there might be situations where you want to highlight the execution of a whole function, or there might be situations where you want to highlight just a specific fragment of a function or a part of your code that you suspect that would be interesting for the observability backend to showcase that, because that might be a source of investigation. For example, one good candidate for you to actually highlight to the observability backend is whoever other invocations you're doing for external databases or external APIs that might incur in some sort of I/O or network invocation. So those are usually kind of time-consuming invocations. So those interactions you might want to highlight, either like wrapping the function that does that invocation using the @WithSpan annotation, or if it's basically a custom code that you are using in your implementation, you can simply using the creation of the span from the tracer that you've created. I'm going to save the changes right now, and I'm going to re-execute that microservice right now so we can have a fresh version of the new code, and then I'm going to send a couple requests to that microservice and see how the observability backend is going to showcase that. So now that implementation is done, I can close it, and then I can start the actual execution of the microservice. So let's execute the run microservice script one more time, and we can see how that goes. So the run microservices script basically forces a new Maven build, because it's important for development purposes since we are changing the code throughout this whole series. So in production, you don't actually need it to create, to execute the Maven build every time you're going to execute a microservice. But since we are progressively changing the code to demonstrate the power of the instrumentation, that becomes necessary. The microservice is up and running. So what I'm going to do now is actually to send a couple invocations to the microservice. So I'm going to perform a curl request to it. I probably have some curl requests previously in history. So I'm going to send one, and I'm going to send another one. So we have now two invocations to that microservice. Now that we have seen how the instrumentation went, let's take a look in the observability backend to see if the tracing timeline now reflects everything that we have done in the code. Now that we're back to the observability backend, let's take a look to see if the new changes that we have done in the instrumentation process reflect what the observability backend is going to show. So I am going to search for all the traces generated by this microservice called Hello App, and hopefully those new traces will include additional information. So as you can see here, there are 4 traces generated. 2 of them were created by the 2 original invocations that when we started this whole troubleshooting process, and the last 2 of them that happened 9 minutes ago were the result of the invocation we have done after that we've introduced the new manual instrumentation. So I'm going to pick up the first one, and I'm going to take a look on the timeline of events to see if they showcase some new information. And as you can see here, they do. So the /hello is the entry point of the microservice, and we didn't create that root span manually. That was created automatically by the OpenTelemetry agent for Java. Therefore, it is the result of the black box instrumentation we've done originally. However, after the Hello App controller hello, you can see that now we have a child span for the build response method, that one that we've created using that annotation @withSpan. So as you can see here, it was automatically included in the timeline of events, and this span that we've created manually from the tracer. So that part of the code that we would like to showcase that encompasses the verification if the response is valid or not. So as you can see now, the microservices now is showing exactly what is doing it. And the lesson here is that when you start using your instrumentation process, only focusing on the black box instrumentation, that might give you a jump start and some sort of a quick win, because you don't have to actually change the code for providing the observability backend with information about what your code is doing. But as we've learned in this video, the instrumentation that is used doesn't provide the enough information that the whoever is using the observability backend might need to understand what your code is doing. That's where you're going to need to use the manual instrumentation. The manual instrumentation is the process of adding the dependencies of your SDK in the code, and then you're going to create some code to highlight the parts of the microservice that you want to showcase for the observability backend. And as you can see, it's not much effort, but it doesn't happen automatically. You have to pull up your sleeves and actually write some code for it. In the next videos, I'm going to show how you can use the same OpenTelemetry SDK not to produce traces, but to create your own metrics. See you there.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.